it's an inequality greater than or equal to. I am told to solve it graphically. Okay, so the first thing I want to do, because I'm told that I can solve it graphically or algebraically, then I am free to combine both of them. So first thing I want to do is pull up my calculator and go to function 1 and put the data in. So I'm going to clear, that function says 16x squared. All right, so it's almost the same as what I have here, but I can type it though. So I just have 16x squared. Then it says minus x to the 4th, x caret 4. So I just put it in and want to find the solution region. I'm going to find the solution region using my calculator. So please, I want you to pay attention. So the first thing I want to do is arrow to the left, to the extreme left. You see that line, short line segment? It's dancing now, up and down. I want to hit enter until I see the line segment change to a triangle pointing down. So it's now a triangle pointing down. That means I want to let you, I would let you know why I should use triangle pointing down. Okay, note that this function is written on the left-hand side. Left-hand side is greater than or equal to 0, and 0 is on the right-hand side. When I put the function in y1, which is y1 equal to, I am changing the function, the expression, to be on the right-hand side of y equal to, which means the inequality greater than or equal to will also change to less than or equal to. So the triangle pointing down is signifying less than or equal to because I moved the function. All right, so that is why I chose less than or equal to. Right now, I am going to graph this function. Before I graph it, I'll check my windows. I actually want to use a smaller window for, let me use from -6 to 6. And then I will go to my y and say -10 to 10. I am looking to see if I can see the turning points. Maybe I will see the complete graph, or I may not. But the important thing is that I want the shaded region to be the solution region. That is why I use the dancing triangle. So because I'm using the dancing triangle, I'll be shading the solution region. So going to graph. The solution region is being shaded. I am not seeing the turning points, but that's okay. The most important thing is that for now, so because we know already the properties, because we already know the properties of this polynomial expression, I can see that the leading coefficient A is negative, and it is a 4th degree polynomial. Every 4th degree polynomial with a negative leading coefficient should be like this. So my graph actually showed me something like this. And the solution region shaded, the shaded solution region that I saw in my graphing calculator looked like that. Okay, so this has told a whole lot of stories. I'm combining my calculator and my algebraic method. So I have seen the picture. A picture tells 1,000 stories. Now I will go to my whiteboard. I'm going to go to my whiteboard and get the equation or the inequality. So the inequality says 16x squared minus x to the fourth is greater than or equal to 0. Step 1 says I should rewrite the inequality with equal sign. So I'll do that. And also I will check to see, is there any common, do I have any common terms? Yes, I do have x squared into 16 minus x squared is equal to 0. That's step 1. Change the inequality to equal sign. Then solve the polynomial equation. So I now have x squared. I want you to note that inside the parentheses, I have difference of 2 squares. And so I can rewrite the difference of 2 squares as 4 squared minus x squared equal to 0. Then I will expand the difference of 2 squares. So I have x squared into 4 minus x into 4 plus x is equal to 0. Then I will find the solution set. It's a 4th-degree polynomial, so I'm expecting to have 4 x-intercepts. 4th-degree polynomial, 4 x-intercepts. Some of them might not actually intercept x, and when it does not, we say that it has a complex solution. But in this case, we do not have a complex solution. We can see 4 x-intercepts. Let me write it. X squared is equal to 0, so I can say x equal to 0 twice. It's a repetition. That is 2 solutions, or that's 2 solutions. And then by 0 product property, 4 minus x will give me x equal to 4. 4 plus x by 0 product property will give me x equal to negative 4. So I have 0, 0, 4, and negative 4. Negative 4 right here. Negative 4. So I have 4 solutions. But since I have 2 zeros, I just 0 and 0 are the same. All right, so I have solved the equation. Remember step 1, change the inequality to equation. I did. Step 2, factor the left-hand side. Okay, I did. And I found all the factors. So the next thing in solving algebraically is draw a number line. After finding the zeros, you draw a number line. The smallest of the zeros is negative 4, so negative 4 right here, 0 right here, 4 here. Then I will go back to my graph. One good thing about allowing you to use a calculator in the test is that you can combine both of them. You can combine algebraic method and graphical method, and which means that your calculator does the heavy lifting. But you have to know what you're doing though. If you don't know what you're doing, your calculator will not write the test for you. Okay, so now after finding the zeros, the next thing is draw a number line and use sign language to find the solution region. The solution region. Okay, so let's do that. So I'm going to pull my calculator again, but before I do that, I want to pick a test point. The first section is from negative infinity to negative 4. Okay, so I'll pick a point from here. I want to test negative 6. The next region is from negative 4 to 0, and a number between them is negative 2. I'll have that as my test point also. The third one is from 0 to 4, and I want to use 2 as a test point. And the fourth one is from 4 to positive infinity, and I will have a test point which is any number greater than 4. So I can test 6. So about to use my calculator instead of doing it by hand, because remember there is going to be 10 questions for 60 minutes. So you don't want to be doing one question for 60 minutes, because no matter how good your one question is, you still don't pass the test. So be careful. All right. Is there any question, first of all? Before I continue, can someone ask a question? Go ahead.
I missed why you put negative 6, negative 2, 2, and positive 6 on the number line.
Okay, very good. Very good. So, first of all, did you understand how I got the zeros of the polynomial? Did you understand that?
Yes, ma'am.
Great. All right. So I now I put the actual zeros on the number line, and that's negative 4, 0, and 4. Now the next step is to pick test points. Pick a test point on every interval. So the first interval is from negative infinity to negative 4. Can you see? From here down, negative 4 to negative infinity.
Yeah.
Yes, okay. So I'm going to pick a test point in that interval. And that test point, you have to pick a point you like. So I picked negative 6. You can pick any number. But I wanted to watch how we test it though. Now, I will also pick a test point between 4 and 0. And I decided to pick negative 2. Is that clear?
Yes.
Good, good, good. Okay, and I will pick another test point between 0 and 4. And another test point between 4 and positive infinity. So I will test every interval. Is that okay from now? Can I continue?
You test them by putting them into the equation to make sure it's true? Is that what
Yes,
you do?
okay. I think you're too fast. Good, good. You're learning. Okay, but you're faster than the class. So I want you to wait a little bit. So does everybody understand why I picked a test point? I want to test each interval to see if they are in the solution region. All right, let me do the test. So please watch. Okay, if you miss it, let me know. I will say it again. So I'm going to pull my calculator up. Because the diagram I have in my calculator right now has shaded region, actually it has done the job. I have used that to know the solution region. So the solution region is between negative 4 and positive 4. But guess what? I have to also show that I know how to do that algebraically. Because you never know if you can go to the next class, your calculus 1, and your teacher might actually not allow you to use calculator to do it. So you should be able to do it by hand. All right, so I'm going to go back to y equals and take away the dancing triangle and make it look like a straight line again. So I'll go to do that. I'll arrow to the left until I get to that dancing triangle. and then I'll hit enter until it becomes like a line like others. Do you see? It's now like others. Okay. Now I will graph. All right, so notice I have there's no shaded region anymore, and that's okay. Now I'm ready to test the chosen intervals. Second quit. Now I'm going to test them, see if they are, I hope you know what we are contesting. We are contesting, we want to show that the points are greater than 0. If the points are greater than 0, if I test any point and that point is greater than 0, it passes the test. But if I test any point and that point is less than 0, it failed the test. Okay, so let's test the first point. The first point at the extreme left is -6. How do I bring down the function in y1? We already know that from unit 1. Go to vars, y-vars, function y1. Ask your calculator to substitute -6 in that function in y1 and tell you the answer. And it did. And it told me the answer is -720. What did we say? If it is negative, -720 is not greater than 0. It is not greater than 0. So this section failed the test. Okay, so I'll go to my number line. This section failed the test, so I'll go to my number line. I'm going to clear some things so let me clear this section so I can draw some vertical lines on that number line and put in the sign language. I'm told to use sign language. Well, this one didn't say sign language, but guess what? Very soon it will say that. So I might as well start using it now. Okay, so I'm going to go to my number line and draw a vertical line from -4. So I'm going to draw a vertical line from here. And this section is negative, and it failed the test because -720 is not greater than 0. Do you understand why it failed the test? -720 is not greater than 0. So that section from -infinity to -4 failed the test. So I'll go to test the next interval. The next interval is from -4 to 0, this interval, this one right here. And I'm using -2 to test. So let's do that. I'll pull my calculator up again. And I can do second enter. I don't have to do vars while vars all the time. So I do second enter. Second enter. It brings down the the argument that I put in before. So I'm testing -2 now. So I put 2 there. And I want my calculator to evaluate -2 for the function in y1. When I hit enter, I have 48. Question 48. Is 48 greater than 0? Anybody? Yes or no? Let me see if you follow what I'm saying. Is 48 greater than 0? Unmute yourself and tell me.
Yes.
Great. Yes. The answer is yes. In other words, the section from -4 to 0 passed the test. Passed the test. Therefore, it is in the solution region. It passed the test because 48 is greater than 0. All right. It doesn't matter that we have found one solution region. We have to test all the sections. So the next section to test is from 0 to 4. And we already picked the test point to be 2. So I'll go back to my calculator and substitute 2. The same thing, I will arrow down. I will do second, enter. That way I don't keep repeating myself. And then I will enter, arrow to the left. I will only remove negative sign, delete. And then I hit enter. 48 again. And 48 is greater than 0. So this interval passed the test. I have to use sign language again. Sign. The sign you put it there is that you're trying to show that 48 is greater than 0. That's why you're putting 48 is greater than 0. You put in signs there. Okay. We need to test the last region. The last region is from 6 to positive infinity. I mean, okay. So I'm testing 6. Test point is 6. Okay, do the same thing, go back to your calculator. So you see you can combine algebraic method with graphical method. It is very important that you know how to do both of them. And then you bring down the last function, second, enter, and change 2 to 6 because I'm testing 6 now. And hit enter. Negative 720. Question. Is negative 720 greater than 0? Somebody. Unmute yourself and answer.
No.
No.
It is
Good.
not.
Good. No, it's not. Okay, so you go and see, you are answering this question to show you know what you're doing. Using this sign language, make sure that you demonstrate you know what you're doing. If you only put in what your calculator gives you, trust me, even my lab maths will give you a partial grade. You want to show you know what you're doing. Okay, so this gives me a negative. Also, it is not in the solution region. Therefore, the actual solution region is from negative 4 to 4. You can now put your answer in. From negative 4 to 4 inclusive, endpoints are included, inclusive. They are the solution region. You showed that with your calculator. Let me tell you, if you're told to solve with calculator and algebraic method, you want to draw the graph and the shaded region in your paper, and also you write the solution region, and you must show the algebraic solution and the sign diagram on your number line. I told you that this question will be in your Math 130, but if you learn it in this class, you will not be struggling when somebody's going to rush through it because it's not a unit for 130. It's a unit for 109, and that is why I want to make sure you understand it. By the way, it's in the test on Wednesday. It is in the final exam. You have to show that you know what you are doing. And by the way, if you paid attention to this one example, you already know it. Any question? Any question? Okay, it's your turn. You're going to do one. I'm giving you a minute to do one. I will quickly navigate to the practice test I gave you. That way you know we are doing both. So I'm going to go to the practice test, which I know you have. The practice test is in Blackboard. If you didn't get it, okay, and you don't want to wait for Monday. Monday is a review day, but if I were you, I'd start doing it today, from today. All right, and I want us, let me give you a number that looks like the one we just did, looks exactly. So I give you 1 minute. I'll give you a minute to do it. All right, look at number 12. Number 12 says use algebraic or graphical method to solve the inequality. You already know it's a polynomial inequality. You see that? You know that the degree is 4, and therefore you are expecting 4 x-intercepts or 4 solutions. You see that the leading coefficient is negative, and it is a 4th degree polynomial, and so the end behavior will be hands down, and both end behavior should be pointing down. You must know the history of the polynomial because you already learned it. So if you know the behavior, if you know the end behavior, you should be able to answer the question. Also remember that you are expecting 3 turning points. For a 4th degree polynomial, the number of turning points is 4 minus 1. So you are expecting 3 turning points, and your complete graph should show 3 turning points. Okay, go ahead. And I'll do it though. I'll still do it. And go ahead and attempt this question. Make sure you know how to do it for your own good, not just to, for your own good, you need to know how to do this. Remember, there are 10 questions in that test. So if you miss 1 question, you missed 10. If you miss 2, you missed 20. All right. We don't have a lot of time in this class right now, so I am actually going to start doing this. Then I'll ask you for help. Let me see if we are together. Okay, so the first thing I want to do is put the function in my calculator, because I'm told to solve with calculator and by hand. By hand means algebraically. So don't you see that the original function, the first function and this one, they look alike? So I will change a few things. I will delete 1 and I'll write 9 there just to transform the equation. So the function is already in y1. Now the next thing is arrow to the left and get me the dancing triangle. And make sure that the dancing triangle has inequality sign opposite to what is right here. Greater than or equal is here, and then I should have a dancing triangle pointing down. Okay, so pull up my calculator and arrow to the left and get the dancing triangle pointing down. Okay, then I can graph. Let me go to my windows and see if I can graph. Yes, so let me graph and see. I don't have to have a complete graph. I just need to see the shaded region. All right, the shaded region I have seen is important. So now I actually know that the shaded region is inside. And you can eyeball the function and see that that function, if you graph it on your paper, it should look like this, like an inverted M. And the shaded region is this. That's what you know. The next thing you want to do is change the inequality to equation and solve. So I'm going to my whiteboard now, and we're going to solve the inequality turned to equation algebraically. So I'm going to move this section. I'm recording this, so if you really want to see it again, you can go back and watch it. Okay, so I'm ready to solve. So I have 9x squared minus x to the 4th is greater than or equal to 0. The first one, step 1 is to change the inequality to equation. So 9x squared minus x to the 4th is equal to 0. Then factor. The common factor here is x squared. I hope you're following. So I have 9 minus x squared remaining equal to 0. Again, I have difference of 2 squares. So I can rewrite this equation into 3 squared minus x squared equal to 0. So I can write it in factored form, x squared into 3 minus x, 3 plus x equal to 0. By zero product property, I want to list all the zeros. Remember, it's a 4th-degree polynomial, so I'm expecting 4 zeros, which is the same as 4 x-intercepts or 4 solutions. So I'm going to list all. Suppose I'm told to list all zeros. The first will be x equal to 0. Again, x equal to 0, because x squared is equal to 0. So there are 2 zeros, x equal to 0, x equal to 0, x equal to -3, x equal to 3. So I have 4 x-intercepts. But because 0 is a repetition, I'm going to draw my number line. I just use 1 0. So put your zeros on your number line. Select the test points. This is how you are showing that you know how to do it algebraically. I said that the calculator will do the heavy lifting, but see, if you don't know what you're doing, the calculator will not do it for you. So pick the test point. Test point should be a point between each interval. And by the way, you could be told to list the interval. So the first interval is from -infinity to -3. The second interval is from -3 to 0. The third interval is from 0 to 3, just in case you're told to list it. And I'm sure there is one in the test that says list the interval. And the last interval is 3 to positive infinity. 3 to positive infinity. So you should be able to list the intervals. And I picked a point in the leftmost interval. We'll pick the point here. And I want this point to be -4. I want this point to be -2. I want this point to be 2. I want this point to be 4. All right, because I'm told to do it algebraically with calculator, a combination of both, I am going to pull my calculator up, go back to that function in y1, and deselect the dancing triangle. So I'm going to go back to function, arrow down to the dancing triangle and deselect it, which means make it look like the original. Okay, then about to graph. Let me, well, I don't really have to. I've already graphed it before, so I shouldn't be graphing. So second quote, I want my calculator to help me with the test point. Remember, you have to isolate your y1 on the main screen. Verse, y-verse, function y1, and test the extreme test point. The extreme test point is -4. And that's the point I chose. You can choose any point in that interval. So I want my calculator to evaluate 4 in that function in y1. Hit enter. The question is this number greater than 0? Somebody. Is this number greater than 0?
No.
No. Good. No. Therefore, this region is not the solution region. Therefore, the region on the left-hand side, which is on the interval from -infinity to -3, is not a solution region. No, not the solution region. Now I'm going to test again. And by the way, you should show the sign. That's why it says sign language. Okay, then I'm going to go back and pull my calculator up. And I will bring down the last argument from my calculator. Then I will test -2. So I just put 2 there. There are things you don't want to repeat. Okay, the test point gives me 20. Is 20 greater than 0?
Yes.
Okay, I just want to make sure that people are not paying attention. So 20 is greater than 0 and is positive. So use sign language. Sign, positive, positive, positive. And it passes the test though. So that region from -3 to 0 is in the solution region. You have to test, like we said before, you have to test all the test points. Even though we have found one solution region, there may be more than, because it's a higher degree polynomial, there may be more test points. There may be more solution regions. So I'll bring down the function again, the last argument again, second, enter. And the next test point is 2, so I will get in there and change that, enter. This test point is positive again, so this is also a solution region. So we found 2 solution regions, pass the test. So we're going to test the last interval from 3 to positive infinity. So let's do that. You must test all of them. Second, enter. You just have to be as fast as you can because there are 10 questions and they are long questions. And you have to do them under 60 minutes. Okay, so you don't have time to start going to Mathway because if you're searching for Mathway, you probably use your time for maybe 5 questions. All right, so this section is negative. Show that it is negative. And negative or anything is not greater than 0. So it failed the test. So we have 2 intervals in our number line, and the number line, this is what, so you can write -3, the solution region is from -3 to 3. Solution region is from -3 to 3. Okay, anyway, we have a review. I have said the most important things today, and if you listen to what I said, you already have 2 questions correct in the test on Wednesday. I have said if you paid attention, and by the way, I'm recording this just in case you didn't get anything. You need to review something, so you go back and review this recording. But I will not keep you more than this because I said I'm going to release you early. By the way, I'm not in school today. I'm sorry, I didn't feel very well. I'm not feeling well, so I didn't want to come over there and give you whatever I have, but I think I'm getting better. All right, so any question? I am going to take the roll right now. If you have any question, you can ask or write it in your chart so I can read it from there. Write your question in the chart. I can read it. By the way, I'm going to take a picture of those who showed up. Okay, we are 23 right now. So even if your Wi-Fi is not strong enough, you can still go back and watch the video. And those of you whose Wi-Fi are not strong enough, I can see that your Wi-Fi is weak. I'm still seeing your name. But let me see if there's any anonymous entry here. I don't see any anonymous entry. Okay, so anybody that showed up will be marked present. Let me know if you have a question. This is the last class before before the test review.